Hi guys, welcome to Pre-Calc 11, Chapter 1.5, Infinite Geometric Series. So we're just adding one word here, infinite. So it's kind of obvious what it means. It just means how many there are infinite terms. But let's just go over the PLOs. We have to generalize a rule for determining the sum of all of an infinite geometric series. We have to explain why a geometric series is convergent or divergent. I'll explain those two terms. And we have to, of course, always solve word problems. So an infinite geometric series is basically, it's just an addition to a geometric series, but it has an infinite number of terms. So there's no set number, it goes forever. So there are two different types of geometric series. One is convergent, where the infinite series has a fixed result. It's basically when the ratio is between -1 and 1. So as you can see, the numbers keep getting smaller. This way you can actually have an end result, like a number. Whereas there's something called divergent, where there's an infinite series where there isn't a fixed result. This is when the ratio is more than 1 or less than -1. As you can see, the numbers keep getting bigger. And if this goes infinitely, you will never get an answer. It just gets bigger and bigger. So when it's divergent, when it's convergent, that's what we want. This is the formula you use. Sum of infinite terms is equal to the first term, t1, all over 1 minus r. R is the ratio. So, and this only works when it's convergent. Let's go to our first problem. Determine whether if it's convergent or divergent. So as you can see, to get from 1 to 3, you have to multiply by 3. To get from 3 to 9, you have to multiply by 3. The ratio is 3, which is more than 1, so it's divergent. This will not work out. So from 3 to 3 over 2, you have to divide by 2. From 3 over 2 to 3 over 4, you have to divide by 2 or multiply by a half. So the ratio is a half. That means it's convergent. This will work. From 6 to get to 2, you have to multiply by a third, and so on, which means the ratio is a third. This is in between -1 and 1, which makes it convergent again, so that works. From 1.5 to 6, you have to multiply by 4. From 6 to 24, you have to multiply by 4, which gets the ratio of 4. So that makes it divergent. This will not work. So I hope you guys understand, whenever you see a ratio that is in between -1 and 1, it's convergent and it'll work. So here we have two questions. 2a shows term 1 is 8, and it shows that the ratio is -1/4. So let's just fill in the blanks. It's actually really simple. So here's our formula. Sum of infinite terms is t1 over 1 minus r. Our first term is 8, and our ratio is -1/4. Once you've subtracted that, you get 8 over 5 over 4, which gives us a final answer of 6.4. That's the sum. And 2b, it has an initial value, first term of -16, but a ratio of 1/3. So we'll put our initial value as -16 and a ratio is 1/3. You get -16 all over 2/3, which gives us a final answer of -24. And the final problem for this section is a hot air balloon rises 25 meters in the first minute of flight. Suppose in each succeeding minute the balloon only rises 80% as much as it did the previous minute. What would the balloon's maximum altitude be? So what's the ratio? It's at 80%, so 80% is 0.8, and that is convergent, so this will work. So again, let's just fill in our formula. What is the first term? It goes 25 meters in the first minute, so that's 25. And we know that the ratio is 0.8, so 1 minus 0.8 is 0.2. 25 over 0.2 gives us a total height of 125 meters. I hope you guys found that helpful. Thank you very much.